Hello and welcome to our presentation. Today, our group will be presenting our project titled TRIAGEWATCH, AI-based emergency triage support. This project was developed for our data analytic and machine learning course, and we are excited to walk you through how we apply data analytic and AI tools to solve a real-world healthcare problem. These are my team member for Group 11, Muhammad Syamil Afzah Hisham, Nur Syuhada Farhana binti Othman, Siti Hafizah binti Muhammad Abidin, FATEN HELMI Nur binti Hashim, Siti Hazwani binti Ramli. Firstly is introduction to the community problem. Emergency departments are often overcrowded with the patient arriving in unpredictable condition. One major issue we discovered in our analysis is mistriage, where patients are either over-triaged or under-triaged. This leads to wasted resources, delayed care, and patient safety risks. There is a clear need for better triage decision support. Why it's important to solve? This issue matters because mistriage can lead to severe consequences. Critical patients may face delay while non-urgent cases consume emergency resources. This also increases cost and staff burnout. By addressing this, we can improve patient safety, fairness in treatment, and overall emergency department efficiency. Next, I will present about the project objective. Our project had three main goals. First, to analyze pattern in triage error using historical data. And second, to train machine learning models that could support better decision making. And third, to develop a prototype called TRIAGEWATCH that could be used in real time to assist healthcare staff.
Okay, thank you, friends. Okay, my name is Muhammad Shamil. Next, we are going to dataset selection. This is a few dataset that we are discussing in our meeting. We got five of dataset, but we just need to choose one only. Okay. The dataset used in this project was sourced from Kaggle and contributed by Iker Yildiz. We choose the topic of effectiveness of triaging for treatment in emergency medicine. This dataset is highly relevant to the issue of mid-triage in emergency department. It includes key variables such as vital sign, age, triage level key task, complaint, arrival mode, and also both nurse assignment and expert assigned in the triage level. These features are essential for identifying pattern and predictor of mistriage and development of machine learning model to improve our triage accuracy. Why this dataset was chosen? Because it was relevant to the problem, real-world emergency data, and support analyzing of mischievous page pattern address. It also linked to our SDG 3, which is good health and well-being, and also SDG 9, which is innovation and industrial infrastructure.
Hi, Assalamualaikum warahmatullahi wabarakatuh. My name is Fatin Helmi Nur binti Hashim. So I will explain about exploratory data analysis or EDA. We use Python and the pandas library to clean and explore the data. Then we created several visuals to help us understand trends, pattern, and problem in emergency triage. Let me walk you through the key of visual and what we learned from them. So as you can see, there is insight written there, but I will explain to you later after I'll explain the graph, all everything. So the first graph is age distribution. This graph shows that the most emergency patients are aged between 50 to 80 years old. This tells us that the older people are the ones who are mostly come to the emergency department. Knowing this helps us to understand why some complaint and triage error may be more common in this age group. The second graph is the triage level distribution. So here we saw that most patients are given triage level 3, 4 and 5, which are less urgent categories. This suggests a possible uneven KTS emergency department. So meaning that the system may be marking too many cases as low urgency even when some may need faster care. Thank you. So the next graph is mistriage count. Mistriage bar chart. This graph shows that while most cases were correctly triaged, we still see clear instances of under triage and over triage. This support the insight that mistriage patterns vary, especially depending on age and symptom. The next graph is length of stay by KTS level, average length of stay chart. From this graph, we notice that patient in triage level 3 had the longest hospital stay, which means they may not emergency critical, but they are still need monitoring, which affect the hospital resources. So the next graph is top 10 complaints. We identified the most common complaints such as abdominal pain, shortness of breath and dizziness are the top 3. These are serious symptoms that can also be hard to diagnose quickly, which increases the chances of mistriage. The next graph is vital sign correlation. The SBP versus heart rate scatter plot colored by mistriage. This scatter plot compares systolic blood pressure and heart rate in its colored by mistriage. Mistriage status. As you can see, there is no clear pattern proving that there is weak correlation between vitals and length of stay. So this means vital sign alone cannot predict how long someone will stay in the hospital or how serious their condition is. Last graph is patient volume versus length of stay. So this graph shows the numbers of patients arriving per hour compared to how long they stay in the hospital. We saw that during high traffic times, especially around 12 patients per hour, the length of stay increased drastically. That this shows how hospital crowding affect waiting time and possibly leads to rush and inaccurate triage. So from all the graphs that I have presented so far, so we can conclude that our key finding were there is weak correlation between vital sign and how long of patient is, or how long the patient stay is. Second one is mistriage depend on patient age and complaints. Mistriage pattern depending on patient age and complaints. Third one is KTS assignment are not balanced and they may affect care accuracy. The fourth one is peak patient hour result in longer stays, stressing the importance of better triaging tools.
Hi everyone, my name is Siti Hazwani binti Ramli. So now I will share about regression analysis. Okay, in this part, we try to predict how long a patient might stay in the hospital. So we use two models, which is linear regression and decision tree. These are both type of regression, which mean they try to guess a number. In this case, they guess the length of hospital stay. So this slide just show the overall goal and the method we use. Next, I will show you how each model did. Okay, now let we see the prediction comparison between linear vs decision tree. So here we can see how the models perform when we compare the predicted length of the stay with the actual one. So on the left, for linear regression, most of the blue dots are created and don't match the real values. Same thing on the right with the decision tree. There's a big gap between prediction and reality. So, just by looking, we can tell the both model didn't do a very good job. Okay, so next, from this slide, it shows the score we got from each model. The first one is MSE, so basically, the lower the better. So linear regression had a smaller error than decision tree. The second one is R2 score. This tells us how well the model fits the data. So unfortunately, both models have negative score, which means they are not good. So from this, we know we might need to try other models or improve the data.
Okay, thank you. Next, we proceed to our prototype design named TRIAGEWATCH prototype. TRIAGEWATCH is a digital solution designed to improve the triage process in emergency department. The prototype was developed using Visili, a user-friendly design tool that allows us to visually map out the interface and core functionalities of the system. So our prototype key feature, first we have patient intake form. Second, we have AI-based key task prediction, style length prediction, risk color code dashboard, complaint based quick summary, filter and search feature. We also have triage, history access, and secure login pane. Okay, this is a few selected screen design for our prototype that we are using VCLI. Okay, but it will be discussing more in the last of our presentation by my colleague. Okay, thank you. Okay, this is tools and method we use for our project. For design, we are using VCLI for prototyping UI and ChatGPT for our content and future planning. For method learning tool use, we are using Python, we use Pandas and Scikit-learn. Then for regression, we are use linear and decision tree. For evaluation metric, we use MAE, MSE, and R2. For pre-processing, normalization, and feature engineering. Okay, how our project support the SDGs? As I was mentioned earlier, is linked to our SDG 3, ensure healthy live and promote well-being. Our project improve emergency care efficiency by reducing mistriage. This directly support SDG 3 by promoting safer, faster, and fairer health outcome, especially in times sensitive situation like stroke or trauma. It also has been linked to our SDG 9, which is foster innovation in health system. Okay, our triage bring innovation to frontline healthcare using AI machine learning in emergency triage aligned with SDG 9 goal for enhancing healthcare system through technology and scalable solutions.
Thank you, my friends. And then we continue with limitation and future work. One challenge was the dataset lack of detail in symptom or diagnose, which limit our model's performance. In the future, we aim to add classification model, use NLP for complaint, and collaborate with the hospital for real testing. Okay, then we go to the conclusion. Triage wash help emergency teams make faster and more accurate triage decision using machine learning. While the current model needs improvement, our prototype show how real-time data can support better patient care. This tool has the potential to reduce mistriage, improve safety, and bring innovation to emergency department. So next we go to the demo and prompt. This is our link for our Weasley project that I will have built in. Um, and then, this is our prototype, TRIAGEWATCH. It has smart decision support tool designed to help emergency staff during triage. Basically, TRIAGEWATCH works by analyzing patient data like vital sign, compliance, then giving quick suggestion on triage level, estimating length of stay and risk priority, all in one place. We built this view using Visly, and it has over 8 interactive screen. Some of the main features include a patient registration page, a dashboard that display patient data with color coded, an urgency level, an AI prediction section that suggests key task level, a strength of stay estimator, a filter and search function for incoming cases, complaint-based summaries and trial history record, and secure login for admin access. All these features are designed to save time, reduce error, and help nurses make faster data support decisions, especially during peak hours or with higher patient load. And that's all for our group. Thank you, everyone. Thank you, Dr. Rias. Thank you, everyone.